First of all, I'd like to start by talking a little more about myself. I've been a Bitcoin advocate for a long time now. I first joined the Bitcoin community in March 2011. This was just before the first huge bubble. So my first major project in the Bitcoin space was co-founding Bitcoin Magazine in September 2011, which is a monthly publication, and we have our own website, bitcoinmagazine.com, where we've been writing about Bitcoin from pretty much every angle for pretty consistently, several articles every week ever since. So around early 2013, the Bitcoin was actually. Around early 2013, Bitcoin started growing really rapidly again. And at that point, I actually made the decision to quit university, where I was studying computer science at the University of Waterloo. And instead, I would go to work for Bitcoin projects full time. So I went traveling around the world. I went to New Hampshire, then I went to Spain and visited Amir Taqi's famous anarchist compound, where I slept on almost a floor for about 2 months, traveled through Europe, visited Israel, and at some point in October I became really interested in this area. It's called cryptocurrency 2.0. So the idea with cryptocurrency 2.0 is we have this amazing technology, the Bitcoin blockchain, and we've used it to bootstrap what's now an $8 billion cryptocurrency. But the question is, can we take the same technology behind Bitcoin? Can we take the blockchain, and can we use it for more than just money? So people have wanted to do things like a decentralized DNS system, for example. That's Namecoin. It's been around since 2010. So in terms of what a DNS system is, basically when you visit google.com in your web browser, there's actually a set of servers that are called DNS servers, and your computer first asks those servers, hey, what IP address do I need to access if I want to visit google.com? So it's essentially the phone book of the internet. So you don't need to remember the IP address of every service that you ever use. You just remember google.com or bitcoinmagazine.com or bitcoin.org, and it all just works. So with Namecoin, it's trying to decentralize that. There's also concepts like colored coins, which lets you basically store or have your own currencies inside of the Bitcoin system. There is a project called Mastercoin, which includes decentralized exchange and includes advanced financial contracts and so forth. There's Counterparty. There's lots of others. So So in the month after that, I started getting into all of these different projects quite substantially. I became very excited about the promise that all of these different ideas bring. But what I realized is that all of the protocols in that space that have been around so far, they're actually quite limited in a certain sense. Like we see protocols these days, if you browse through Bitcoin Talk, people are coming up with these currencies that have like 30 different transaction types. They're saying, oh, we have a feature for doing decentralized exchange. We have a feature for peer-to-peer gambling. We have a feature for making your own currency. We have a feature for decentralized DNS. We have a feature for financial derivatives. We have a feature for peer-to-peer insurance or whatever. And they're coming up with this large array of transaction types, where if you look at the entire size of the protocol specification, it becomes enormous. The protocol is going to become pretty much impossible to re-implement. There's bound to be at least 10 critical security bugs in there somewhere, just because it's so huge. And ultimately, there's still only a limited range of things that you can do with it. The only things that you can potentially do are those transaction types that it allows. So if someone creates this protocol that lets you do 100 different things, and you want to do something 101 that they didn't think of, you have to either make your own protocol or you have to convince the developers to add a transaction type for you. So what I realized is that there's actually a much more elegant way to allow people to do this sort of thing, which is instead of having all these 100 different transaction types, each for every little potential use case, you have a cryptocurrency with a built-in programming language. And if somebody wants to make a feature, or if somebody wants to make a transaction type, they can just write their feature in your programming language. They just write it on top, and it works. And that's basically what Ethereum is. So I first originally released the Ethereum white paper at the end of November 2011. 2013. I released it basically in an email blast to about 15 people. Then over the next few weeks, I started pushing it out more and more, and the community started forming. Quite a few very competent developers jumped onto the project. So we have Charles Hoskinson, who is the founder of the Bitcoin Education Project. He's also an academic mathematician who worked on the Goldbach conjecture. We have Anthony Diorio, who is the founder and the executive director of the Bitcoin Alliance of Canada. We have Gavin Wood, who is our lead C++ developer, and he's been the one maintaining one of the two main implementations of Ethereum to date. And we launched, or we officially announced ourselves on January 23rd. We launched the testnet on February 1st. We launched the third version of the testnet, I believe, on February 28th. And so here's where we're at now. So right now, in terms of where we are with the Ethereum project, we have the third version of our testnet out. The third version of our testnet fully supports contracts. So what that means is that there is actually a window where you can write code. You can write some kind of contract. You can write a contract that replicates the functionality of Namecoin. You can write a contract to make your own currency. You can write a contract to do decentralized exchange. All of the things that you can theoretically do in Ethereum, you can actually do them. You can click a button. You can compile it down into Ethereum assembler code, and you can push the contract into the test blockchain. And you can actually see it work. So it's not even just a white paper anymore. The technology here is pretty much actually ready, at least in its initial form. So we also directly integrated the Namecoin contract into the client. So if you want to register something on the Ethereum blockchain, you can. We've got a decentralized phone book running that anyone can use. So yay, we're already doing something useful even now. The other thing from a technical standpoint is that we are looking at a whole bunch of different technical challenges. So, for example, some of the issues that people have raised have been specifically in this area of blockchain scalability. You know, how could Ethereum work if everybody has to download all of the blockchain data and process all of these contracts? And so we're coming up with designs to both make it more efficient and potentially even set up designs where not everybody has to process every transaction. So even in Bitcoin, there's this concept of light clients, where a light client is basically just downloads only the small part of the blockchain that it needs. So with Ethereum, what we're looking to do is we're looking to find ways to make light clients more powerful. Right. So the other major update at this point is that we had been hoping to launch our pre-sale on February 1st. So this is the way to get into Ethereum financially, which would be that we would be selling Ether at a rate of 2,000 Ether for 1 Bitcoin, and Ether would become the internal currency of the Ethereum network. So you would be able to So Ether would be like the BTC in Bitcoin, or like the XRP in Ripple. It's sort of the glue that holds the system together. If he wants to run a contract, you would have to pay transaction fees denominated in Ether. And if you want to exchange between two different assets on the Ethereum network, chances are Ether would be the intermediate currency that you would be doing it through. So it's sort of like the reserve currency of the network. Now, we were hoping to launch the sale where you would be able to buy Ether for Bitcoin. We had to delay that for a combination of reasons, partially in order to better flesh out the business plan, partially in order to better flesh out the terms, partially for legal reasons. So we have been working hard at all those things all the way through February and the first week of March. So from an organizational standpoint, our current situation is that we have an entity registered in Switzerland. And the reason why we're looking at Switzerland as a jurisdiction is because, first of all, Switzerland is very well known for its very friendly banking laws. It's much easier to do anything related to innovative finance in Switzerland than it is in something like the United States or even Canada. Another country we were looking at was Panama, which has some similar properties, but we decided that Switzerland is likely to be more stable. And the other thing is that we're working heavily with Open Transactions. So Open Transactions is the group that's trying to essentially do cryptocurrency technology based off of a federated server system, where there would be servers, except those servers would actually be publicly auditable, and so you could actually so Open Transactions technology allows you to do a lot of the same things that Bitcoin does, except with much lower fees. You could do high frequency trading, 10,000 transactions a second, almost no charge. You could do microtransactions, and it's not going to be blockchain based and decentralized in the same way Bitcoin is, but the servers are auditable, and so it's very low trust in that sense. If Mt. Gox had been running an OT server as their backend, we would have known. We would have known something was up. They would not have been able to get away with disappearing $400 million worth of Bitcoin out of existence. So we're working heavily with Open Transactions in Switzerland. We're working heavily with the Swiss government, and we will have more updates on that coming soon. So we are definitely quite close on that front. Right. So the other thing I would like to talk about today is to hopefully give an introduction into some of the deeper levels of how the Ethereum technology works. So unfortunately, I don't have slides available right now, but so what I am going to do is I'll explain in detail what Ethereum contracts are, how they work, how you can use them to replicate certain functionalities. Also talk about some very interesting use cases. Right. So in general, the definition of an Ethereum contract is that an Ethereum contract is sort of like an autonomous agent that has some code, and it lives on the blockchain. And every time you send a transaction to an Ethereum contract, that contract runs. It executes its code. So what can Ethereum code do? It can send transactions. It can read the contract's internal state, and it can modify the contract's internal state. So, just as a simple example, if you wanted to implement something like multisig as a contract, then what you would need to do is you would need to have a contract where that contract would store the addresses of 5 people, and then it would every time. First of all, you could just send money into the contract, and normally that would do nothing. But what you would also be able to do is if you send money into the contract, but the transaction has a special flag in it, that would be considered an authorizing transaction. And so the contract would actually look at the sending address of the authorizing transaction. It would see if it matches up against any of the 5. Then if it does, it would record, oh hey, this person authorized this withdrawal, and then you would be able to essentially sign or authorize any withdrawal right on the blockchain one by one, and then when the withdrawal counts got up to something like, say, 3 out of 5, then it would just automatically send the transaction that you had wanted to send. So how is this more powerful than Bitcoin? Now, Bitcoin can do multisig too. But here's what Bitcoin can do 2 out of 3. Bitcoin can do 3 out of 5. But here's something that Bitcoin can't do. 1 out of 5 up to a maximum of $100 per day. 3 out of 5 up to a maximum of $10,000 per day. 5 out of 5 gives you everything. So Bitcoin's multisig has no way of allowing that kind of granularity. So if you were at Ryan's presentation 2 hours ago, where he was talking about how what he wanted to do was essentially introduce very banking-like consumer protections into the Bitcoin ecosystem. So the way the banks work is that they have withdrawal limits, and if you want to withdraw up to $100, everything's fine. And if you want to withdraw something like $10,000, you're going to want to go through some more authorizations before the transaction actually clears. So that's something you can do with Ethereum. You just write the contract so that it actually checks what the size of your withdrawal is, and then based on that, it can switch. It can say, oh, I require 1 out of 5 for this. I require 3 out of 5 for that. That's just one use case. So it does the same sort of consumer protection stuff that Bitcoin does, but more powerful. Here's another use case. Unlike Bitcoin, Ethereum does recurring billing. So all you need to do is basically have a contract which allows one specific entity. So say you have a contract which allows Netflix to withdraw a maximum of $15 per month, and it could do it. The whole thing would be essentially trust-free. You would not need to trust some centralized entity to store your Bitcoins for you and automatically forward them on at some specific rate. So now in that particular, those are the last two cases. There is one somewhat important point, which is I use this idea of a US dollar. Now, so there is one point of trust there that we do need to keep in mind, which is there has to be some entity or some set of entities that's actually keeping a price feed for Ether or for some cryptographic asset relating to the US dollar. So you have to have some entity saying one Ether is currently worth 17.3 US dollars, and then the price feed operator would actually need to either feed that into the blockchain, or it could keep it off chain. It could just sign the price feed, and then if you want to use the price feed in the contract, you would actually have to include the signed data as part of the transaction. So in both of those setups, you could do that, and there is some trust involved, but there are a lot of ways to mitigate the trust. So for example, you could rely on a whole bunch of different price feeds, and you can take the average of all of them. That's an entirely valid strategy. So that's just one use case. So basically advanced escrow, more complex consumer merchant interactions. Here's another use case might be something financial derivatives. So for example, one of the big holy grails of cryptocurrency has been this idea of a crypto US dollar. So can we have an asset on the blockchain that has all the same cryptographic properties that Bitcoin has, but it also has a stable value? Because merchants, they want to accept Bitcoin, they love the convenience, but they don't necessarily want the volatility. They don't want to know, oh hey, I'm accepting this asset that might decrease in value by 20% tomorrow. Now there are obviously some solutions which basically involve going through payment processors and getting US dollars. But the issue there is that on some level, you're still sacrificing some of Bitcoin's efficiency. So how do you solve the problem? So here's solution one. The first solution is something based on colored coins. So the idea is that you have some entity which releases its own currency, and it says each unit of this currency is redeemable for $1 US. As long as you can trust the issuer, the mechanism works. So people can trade these coins around. They're cryptographic assets. You can transfer them just as easily as you can transfer Bitcoins, or just as easily as you can transfer Ether. And yet their value is going to be $1 US for as long as this central backing entity exists. However, as we know, central backing entities have their problems. Cough, cough, Mt. Gox. Now, even without Mt. Gox, there are still important legal. It's still very difficult to set up one of these. It's very difficult from a legal standpoint to interface with a financial system. It's very difficult from a banking system. In many countries around the world, banks are notoriously hostile to Bitcoin, unfortunately. So the question is, can we do this? Do the cryptographic US dollar, but bypass banks entirely? As it turns out, you can. The solution is you use a hedging contract and use a price feed. So here's the solution. We make an Ethereum contract. I put in $1,000 worth of Ether. You put in $1,000 worth of Ether. The contract as soon as that happens, the contract records records the fact that we both put in $1,000 worth. After 30 days, the contract will then give you back $1,000 worth of Ether, and it'll give me the rest. So the contract will actually look at either one price feed or a combination of price feeds, and it will determine exactly how much Ether you need to get in order for you to get exactly $1,000 back, and I'll get the rest. Now there are two small vulnerabilities to that. The first vulnerability is, well, what happens if Ether drops by more than 50%? So that's pretty much a solved problem in finance. That's called a margin call. So there have been a lot of leveraged trading platforms on Bitcoin, and the way they all work is that if the value of Ether drops by 50%, then I have the right to immediately cancel a contract and say, I'm claiming $1,000 worth. Or rather, you immediately have the power to cancel the contract and say, I'm claiming my $1,000 worth of Ether now, and I'm going to immediately place it into another contract. So, and then so in that way, you're basically preventing yourself from actually losing everything, from losing anything actually, because you get your $1,000 worth of Ether back, you immediately put it into a new contract, and now Ether would have to drop by 50% again in order for anything to happen again. And even then, you could be offline and you could put your Ether into yet another contract. So that's essentially how the solution would work. And there are potentially ways that you could improve upon it. Like instead of having a contract that's locked for 30 days, you could actually implement an interface so it's more like a subcurrency, where you could actually move units of the currency around and you can pay people in it. That's entirely doable. But the point there is in terms of so what are the properties of that? Now, obviously, you do not need any kind of banks. You do not need any kind of exchanges, any kind of entities that are interacting with banks. Now, you do need some kind of trust, because you do still need some entity to provide reliable price feeds. But you can very heavily decentralize that. You could say, let's have Bloomberg provide a price feed, let's have Winklevoss provide a price feed, let's have Bitstamp provide a price feed, and let's have 6 other organizations, and we're going to just take the median. So that basically removes the need to trust any single organization. There might even be ways that if you want to decentralize it even further, you could even devise some kind of mechanism based off of proof of stake voting. Now what's the other major benefit? So the other major benefit is that even though you haven't eliminated trust, you've massively reduced it. First of all, you go from trust in one entity to trust in 5 out of 9 entities. Second, though, you go from trusting an entity not to steal your funds to trusting an entity not to screw around with a price ticker. The third thing is that instead of relying on an entity that needs to have an active bank account and could potentially get the bank account closed down, seized, or whatever, all you're doing is you're relying on an entity that just provides a price feed. A price feed does not require banking infrastructure. A price feed is freedom of speech. That kind of a setup becomes much harder to prevent, much harder for banks to get in the way of. So that's another example. So it's not quite the perfect, fully trust-free cryptographic US dollar that we want, but it gets quite close to that. Another idea is that we've been talking a lot about this concept of decentralized Dropbox. So what is this decentralized Dropbox protocol? Essentially, suppose that I have a 100 gigabyte file. It could, yes, Anthony? Okay. Suppose that I have a 100 gigabyte file, and I want people to, that 100 gigabyte file represents all of my photos. It represents my hard drive backup. It's an encrypted version of everything, of something that I really absolutely want not to lose under any circumstances. So what do? I upload this onto the blockchain, and I can create a contract which automatically sends Ether every hour to people who can prove that they own the file. So there's a cryptographic mechanism for actually proving that you possess some certain set of data. The most simple way to do it is just a random mechanism based on Merkle trees, where the contract picks some random data based on the previous block hash, and then it uses that to pick a random branch of the file. And if you prove that you own that branch, then you can claim your 1 ether right there. So with this kind of setup and with a few convenience layers on top, you could basically implement a decentralized Dropbox. So the reason why that's fun is because it's not just for the consumer side. It's not just for the people who want to back up their files. It's also the fact that now you can participate in the server side. It's not just Dropbox making money off of this. You can earn money with your own hard drive. Here's another idea. This is something that I have to credit Donald Lumsden for. I'm not sure if he's here. But here's the idea. So we already have BitTorrent networks. We have file sharing networks. The problem is, however, is that with a lot of those file sharing networks, if you want to get some kind of very mainstream file, sure, you can get people seeding it. But if you want something that's more obscure, chances are nobody's going to be seeding it because there's no incentive to. Nobody's rewarded for storing data. Nobody's rewarded for seeding on a BitTorrent network. So how do you improve that? Well, with cryptocurrency, the obvious answer is we make a paid version of BitTorrent. So you would need to actually pay. You would need to actually pay per packet in order to download portions of a file. Now that already by itself is a massive improvement, but that's not even the fun part. Here's the actual fun part. For every single file, so every file can be identified by its hash, and for every single file, we're going to have a unique currency. And if you want to download some packets of one particular file, you would have to pay in that currency. Now, what's the benefit of that? The first person to upload the file automatically gets a pre-mine of 1 million units of that currency. So the point of that is that you not only have you created a version of BitTorrent that incentivizes people to seed, but you've also created a version of BitTorrent that incentivizes people to create to create any kind of works in the first place. So whether that's art, whether that's software, all you do is that you'd basically, if Hollywood wants to release like Iron Man 4, they can just publish it right onto this paid BitTorrent network, and they would get a pre-mine of a million units of this currency. And because everybody's going to need to get those units in order to download the file, the value of the currency would go up very quickly, and they would make a profit. You're not going to need to implement any kind of DRM. You're not going to need to try and restrict people or sue people in order to earn money. All you need, you would basically let people pirate it, and you just earn money off the currency supply. Yes.
But can't I just buy one and credit my own copy at a lower price?
Well, no, that's the thing, is that you're not actually charging a price, right? Because sure, you can potentially take the file and you can change 1 byte and you can republish it. But why would anyone download your version instead of the original? That's the thing is that so there's a distinction between placing the file and seeding it. So you're not actually putting it on the network at a price. You're saying, so yes, people can resell it, and people will resell it. But when people will resell it through your network, they're going to resell it. The system will require them to resell it using this same currency, and that currency has. And so the more people are seeding the network, the more people are reselling it, then the more valuable that currency becomes, and you have 1 million units of that currency anyway.
And we do have dedicated question and answer time coming up right after the presentation.
All right, perfect. That's more questions. Well, so I'll just so those are just some ideas. Some of them could turn out to be impractical.
Right now.
Some of them could turn out to be practical. Some of them could turn out to be revolutionary. We really don't know. With Ethereum, we're not trying to restrict you to specific applications. We're not saying this particular contract is the way of the future. We're saying we are the Lego of cryptocurrency. With Ethereum, you can implement whatever idea you have. You can implement it. You can write it in 20 or 50 lines of code, and you can implement it as a contract or as an application, and you can actually try it out, and people will do it. And if it works, then it works. I think the most exciting applications of Ethereum are going to be the ones that I haven't even thought of yet.
Thank you. We're actually going to have a panel coming up to field the Q&A, and I will have the audience mic here. If you would please form a queue for any questions so that we can take them in an orderly manner.
Sure. So I was wondering about how would, oh, sure.
Vitalik, I think they're turning off your lapel mic and just giving you the wireless one there.
How would a contract send transactions? Does it have private keys or
So-
how does that work?
Okay, so the way that contracts are not the transactions that contracts sends, they're not actually ever going to be represented anywhere. They're not going to be signed. The idea is that the contract is just created and or the transaction is created and it just exists momentarily inside of the memories of all the miners processing the blockchain. So it's the contract is not actually going to contain private keys, but it's still a rule enforced by the system that only a contract has the power to send transactions from itself.
Thanks.
So are the Ether like another coin?
Yes, so Ether is like is sort of like a central it's like the internal crypto fuel of the Ethereum system.
Okay. And you said you're selling Ethers in the beginning for like 2,000 per
Yes.
one Bitcoin. So does that mean you guys will be like pre-mining some to fund the project, or?
Yes, so there will be an initial quantity of Ether will be pre-mined, and then it'll also be mined, and so we're thinking something like 30% of the initial amount pre-mined will be released every year, and that'll keep going forever.
Okay, I see. And the incentive for the miners would then be to collect fees.
To collect block rewards.
And block rewards.
Yes,
and
block
fees.
rewards and fees.
Okay, thank you.
Hi, Vaskin Kasoyan. My question is regarding software development life cycles with the contracts. So if you put a contract out there that is faulty and you need to upgrade, what is the upgrade path for, what's the deployment path? And then on the other side, what's the upgrade path for moving your
Right.
users to the new contract? I don't quite know how to phrase the question.
Right. So that, first of all, that somewhat depends on exactly what your application looks like, because there's really two ways to do stuff on Ethereum. One way is you come up with some protocol which involves people just creating their own contracts. And in that case, you just tell people to create this new kind of contract instead of the old kind of contract. So something like a decentralized exchange offer might end up working that way. The other option is, of course, if you have one contract and everybody works through it. So unless you include an upgrade path, the upgrade path is not going to exist. You're pretty much just going to have to create a new contract. And
So the contract would have to include a facility to move them to another contract.
Yes. So
and
the
you would trigger that somehow?
contract. So if you want to create a contract that is updatable, then you would need to. Well, actually, the right way to do it would be to keep the same contract, but you would basically do a self-modifying code sort of setup. So you would have the contract have a rule where if a specific address sends in a transaction with some certain data, then that would actually update the code of the contract with the new data.
Sounds like a best practice or an IDE that needs to.
Yeah, we are looking at developing IDEs for all this stuff.
Okay, and in your example, if you can in the example where you guys did a Namecoin type of implementation, a DNS implementation, how would you, like if you found code in there that's wrong, how would you currently move it? Like, do you have that provision in there?
Unless you deliberately create a mechanism for updating a contract, the contract is unupdatable. It'll be just a buggy thing that sits there forever.
So let's say you didn't create that in your current implementation.
No, we did not.
So what would happen for those?
Well, we know that because the Namecoin contract is five lines of code,
Right. Yeah,
it's
I get
not
that
broken.
in that example. Yeah.
But in general, we expect all of the interesting Ethereum applications to all be under 100 lines of code. So there will be substantially less space for errors. Right.
Okay. Thank you.
Oh, hi. I'm Alex. You've mentioned apps a couple of times, and I know a lot of those things are under development. Right now, we have transactional contracts. So can you speak more about apps and how that's going to work and how close that ties to the contracts or separated?
Yeah, sure. By the way, this is Gavin Wood, and I'm Anthony Dior. We're both part of the core teams of about 100 people that are working on Ethereum right now from around the world. And just going to tell you, we're going to be, over the next few weeks, we probably will be doing the product sale. We don't have an exact time ramp, but we'll let you keep on going that.
Cool. Yeah, so apps are an interesting point of Ethereum. The idea is that we're going to release a reference client that will effectively look like a browser, like a sort of Google Chrome sort of effort, where the apps are right there presented to you just as a bunch of icons. So the window that you get with Ethereum will look very different to the window that you get with Bitcoin. With Bitcoin, you have your transactions, you have your balance, and so on. With Ethereum, it'll basically look like a browser window with maybe a balance in the corner to show how much Ether you have, and then the apps themselves will exist as probably HTML, JavaScript, CSS packages that are probably going to be distributed either on the blockchain or through BitTorrent. So decentralized distribution of apps using developer-friendly technologies to bring, crazy levels of functionality, all backed by the blockchain and with no separate I/O. So you can be guaranteed they're sandboxed and therefore secure. They're not sending your data to some random server across the world.
So I love what you're doing. I think it's great. You're on your own blockchain. You're doing this all on your own. It's great. One of the questions, one of the concerns that a lot of folks have is with all of this phenomenal functionality that you're adding, how the security is handled. I mean, your sandboxing you mentioned, but the details of that really matter. The more functionality you add, you're exponentially increasing the vulnerabilities to exploit or fraud or other uses of it.
So I think it's important to remember we're not actually adding functionality per se, right? We're stripping things down, keeping it extremely simple. And any functionality that we do add is contained in the virtual machine. So this idea of having a set of very simple instructions that are trivial to audit in terms of their state changes. And so actually the security model compared to certain other altcoins becomes quite a lot simpler to audit and to prove that, in fact, there's no way of exploiting it.
But yet far more complicated than, say, Bitcoin, right? I mean, it's a Turing-complete scripting system, right? So you have a lot more functionality. Right?
Yes.
So is there, I guess really my question is, there ought to be some structural model in order to do that sort of auditing, because you say, oh, well, it's very auditable, but that has to be done by people that know how to do it, and obviously usually independent of the people that are making use of it. I mean, you're mortals that are deploying this and trying to use it for business purposes aren't going to be able to do that sort of thing in most cases.
So it certainly will be security. It'll be very comprehensive.
Any reward system for those folks that are doing the auditing?
Say again?
Do you do any sort of reward system contemplated for the folks that are doing the auditing in some kind of trust basis where the people who can do this auditing can develop a reputation for having done so, sell their services, do that sort of auditing? I mean, is that been contemplated?
We envisage a lot of third-party, a lot of third parties coming along and selling such services.
All right.
It will be third-party friendly, very third-party friendly.
So I'm an open transactions programmer, and I can tell you we're all very happy that you guys have come on and decided to work with open transactions rather than against it. But my question is, what if I make a contract that does a while fork, and then I send some coins to it? Does it fork forever on the...
Oh, you mean an infinite loop contract?
Yeah, or, what if I make a contract to make your that will set your computer trying to solve some protein solve or something like that?
So it'll go broke really quickly.
How much ether do you have to spend?
So contracts have to pay a transaction a fee for every computational step that they take. So you will eventually run out of gas.
So, like every registry move, every
Yes.
ad, every...
Yes. Every registry move, every add.
Okay, so how will that be calculated?
You count it, like, there is a rigorous definition of a computational step, which is we have a while loop that processes through the opcodes, and every time the loop runs, you subtract 1.
Interesting, okay. Thank you.
Yeah, that's actually one of the major reasons why we are not, quote unquote, just using Lua or whatever. Like, a lot of people have made that comment. Why don't we just use an existing programming language? One of the major reasons for that is because we also have this special requirement of having a rigorous definition of what it means to take one computational step and the ability to stop in the middle with a defined state.
So a state like a fork state, or intentional, array overreach, or something like that, that would specifically cause a seg fault.
Yeah, well,
how would that be calculated in?
Right, so if there is something that would cause a seg fault, so for example, if you try and pop from the stack and there's nothing there, or if you try and like do an elliptic curve multiplication and the values are too high or something like that, then basically just automatically exits from contract execution.
Okay, interesting. Thank you.
Is just
the idea of the distributed DRM was fascinating, and sorry for going out of turn there, but I just had to ask. So I must be missing something, because it doesn't actually protect the content.
No,
it just charges for the download.
Yeah, the point isn't to protect the content. The point is that you have this mechanism where people can charge each other for downloads and uploads in such a way that you're doing it with different currencies for each file, and so the creator of the file gets a premium and benefits from that. So the more trade that there's going on in the network with relation to a specific file, the higher the value of the currency becomes, and the more the creator of the file profits.
Is it the creator of the file or just the server of the file?
Well, the original person to post a file to the network.
Okay, now that's an Ethereum app.
That's an app that can be implemented on top of Ethereum.
Okay, so it has its own currency, but then I can duplicate the whole app and then have copies of things that were in that other app.
Like, potentially you can duplicate anything, but it's a matter of why would someone use your duplicated version instead of this version.
Okay, I understand. Thank you.
We still have a bit of time if there are more people that want to come up for a Q&A.
So what's the network transaction time in Ethereum?
So the block time is 1 minute, and we have the same. And in terms of transactions that are less than 1 minute, we'll have the same properties as Bitcoin.
And is there a limit on the number of Ethereum or Ether there is going to be produced? Or?
So unlike Bitcoin, the mining reward is not going to go down. So it'll be a fixed amount released per year, forever.
So it's not deflationary.
It is deflationary in the sense that the inflation rate goes down to 0% eventually.
Okay. Thank you.
Hi, I'm Jonathan Lieberman, and I'm super excited about your project, but I'm a little concerned that it's an enormous distributed bug bounty where every Ethereum contract that has a bug in it with stored value is just waiting for someone to uncover it and strip all the stored ether out.
It's entirely possible, although so that is definitely something that we will need to think about also and include functionality for easily detecting bugs in the development environment. I would say at this point the best answer is that, once again, because this is really like the concept of Turing complete scripting has only been around for really like a really short amount of time. So the best applications of all of this are probably going to be in like under 100 lines of code. So it is going to be like, for example, our Namecoin contract, that's 5 lines. So in terms of all these applications, there are a substantial number of applications where, unlike with normal software, you actually can say, yes, I am 99.99% certain this is bug-free.
I guess. I mean, Apple's OpenSSL bug was in not very many lines.
Well,
it doesn't take many lines to have a bug.
Yeah. I mean, it's a combination of having few lines and of making it easier for people to detect bugs, and also for cryptography, we'll have standard libraries for that we'll be scrutinizing especially.
Well, thank you. I'm excited.
One last question.
You're barreling down the track very rapidly. Good luck. Curious as to how your structure, your organizational structure is evolving in such a rapid manner. How many programmers have you got? How are you attempting to line up more programmers? How do you see yourself
Right,
growing?
so that's an aspect that I actually somewhat forgot to talk about in my presentation, our organizational structure. So what we are going for is this sort of hybrid model between a traditional centralized organization and something fully distributed. So our ecosystem has multiple levels to it. There is the bottom level, which is basically creating the protocol. Then there's the level which is just implementing the clients. Level 3 is actually writing the applications, and level 4 is all the businesses that are going to be interacting with the applications. So our general idea is that the lower levels are going to be more controlled by our core teams. So we have myself leading the protocol design, Gav and Jeff, who's our Go developer, and leading the client development side. And then for things like app development, and where we really need to get a huge number of people going, we're not even hoping to control that. We are hoping to see people out of their own initiative coming up and starting to write contracts, to write applications, and to develop all these things pretty much completely independently.
And we also have branding teams, we have marketing teams, we have 30 or so Skype groups right now that are full of people that are helping us with the project right now. So that's how we are growing the infrastructure and growing the team.
Also, one more thing I wanted to call attention to, which is we also have this effort, which is a cryptocurrency research group. So what this is that this is a collaborate. We're hoping to turn into a large collaborative effort where we are already talking to two important academic cryptographers, Neil Koblitz and Alfred Menezes from universities of Washington and Waterloo. And we want to come up with a group to actually help solve some of the hard problems in cryptocurrency. So tackle issues like blockchain scalability, tackle economic issues like price volatility, question of setting fees. Is it possible to make an ASIC-resistant proof of work algorithm? What's a good proof of stake algorithm? So all of these problems, where if they could be solved, could potentially make cryptocurrency much better. So these are technologies that are almost certainly not going to be out in time for Ethereum 1.0, but probably will be out in time for Ethereum 2.0.
And we're also having a lot of strategic partnerships with different wallet companies and exchanges and even ATM companies that are looking to put Ethereum on their ATMs. So it's building the community through people that are already out there and make sure that once Ethereum does come out, we have the support systems in place, which we think is lacking on a lot of other alt currencies right now.
Thank you. It was very informative. Let's give a warm round of applause to the Ethereum team.